Hi, welcome back to McClutchy Maths. This is our 6 videos in this series of quadratics, and today we are looking at some applications, how to use quadratics for problem solving in practical situations. So there's a lot of prerequisite knowledge in here, obviously assuming you've watched advanced algebra as well as our first 5 videos in the series, but also you know a little bit about other topics as well, which you'll see when we get to that in a moment. Before we get there though, let's talk about how to engage further with the channel. You could consider liking and subscribing and hitting the notification bell so that you'll know when videos 7 and 8 are out. You could also consider saying thanks by hitting that little love heart button and donating $2 to the upkeep of the channel, or why not tell us in the comments or share it on your Class 1 note. Okay, let's talk about some problem solving, about where we actually see a quadratic model in real life. Well, things like projectile motions. Projectiles such as when I throw a ball into the air or when I let off a rocket. These things move in an arc, okay? And if you were to graph most quadratics, they will look like a nice perfect curve. Okay, we also have applications in area and surface area. So today we're going to do a few problems with those contexts, and hopefully this will help you to solve problems for your exams. So first worked example. The area of a rectangular block of land is 28 meters squared and its length is 3 meters greater than its width. Work out the dimensions of the block of land. Dimensions meaning the length and the width. We've got to work out what they are. Okay, so this is a little picture. I always like drawing a picture. I've got my area in the middle and I know that my length is greater than the width. So let's make the width y and we're going to make the length y plus 3 more meters. So straight away you can see that I've got these two variables here. You could use different letters if you wanted to. Okay, so let the width be y meters. That's what I've done here in my picture. And my length will be y plus 3. This is a good statement to make so your teacher knows what you're talking about. So we know area is length times width. So the area is going to be equal to this times that, and we know the area is 28. So if I expand these brackets out now and solve for y, I'm going to end up with y squared plus 3y equals 28. So now I've got a quadratic and I'm going to solve it using the null factor law. So let's transpose this so that everything is on one side of the equation and zeros on the other side. And I've now got this monic quadratic that I can look to solving. So I'm going to consider those factor pairs of negative 28. One will be positive, one will be negative, and they need to add to 3. So I already can think in my head, well, 7 and 4 multiply to 28. So one of those is going to be negative, and one will be positive. So positive 7 and negative 4. So there we go. If I multiply those together, I get negative 28. Add them together, I get positive 3. That's my factor pair. Okay, the next step is to have a look at what those are. Y minus 4 multiplied by y plus 7 is going to equal 0. Now we can solve using the null factor law. So that means I've got this equation here equals 0, this equation equals 0, which means that y is either going to be 4 or negative 7. My width is either going to be 4 meters or negative 7 meters. Now we know widths cannot be negative numbers. That's not logical. So that leaves us with only one possible solution, and that is that the width is 4 meters. But we're also asked for the dimensions. So the length is 4 plus 3, which makes it 7 meters. So this is one of these examples where I would recommend that you're using your words as you go to explain logically what you're doing. So even a little statement like this here is like an evaluation of reasonableness. That's really important in these complex unfamiliar style questions. Worked example 2, solve for m using Pythagoras' theorem. So in this particular case, we're told a strategy to use, and this is pre-assumed knowledge. C squared equals a squared plus b squared, and 10 is our hypotenuse being c. So let's substitute that information in. So I've got 10 squared equals m squared plus m plus 2 all squared. Okay, so now we want to solve this to get m all by itself. Let's expand those brackets. So 10 squared is 100. And then I've got the m squared here. And if I expand that out, I've got m squared plus 4m plus 4. Now let's collect some like terms. M squared plus m squared is 2m squared. And we're going to bring it all to one side so that 0 is on one side. So we've got the 4 here. We're going to take that to the 100 to the other side. We end up with negative 96 because 4 take away 100 is negative 96. So they all have a common factor of 2. So that is what I'm going to divide everything by first before I get started. It simplifies things a lot. So now I've done that and it makes m squared plus 2m take away 48 equals 0, which makes things much simpler to be working with. So now what I'm going to do is factorise pairs of negative 48 that add together to make positive 2. So I could go through all of them. 48 times 1, no. We need two numbers that are pretty close together that when they add together they're going to make 2. We know one's going to be positive and one's going to be negative. So my factor pairs are going to be 8 and negative 6. 8 times negative 6 makes negative 48. 8 plus negative 6 makes positive 2. That is my factor pairs. So what I'm going to do now is I'm going to put them into brackets. M plus 8, m minus 6 equals 0. And I'm going to use that null factor law to solve, and I get m is equal to negative 8 or positive 6. If m is equal to negative 8, I've got a side length that's worth negative 8. That doesn't work. Okay, can't have negative side lengths. And same down here, negative 8 plus 2 makes negative 6. Can't have a negative side length. So the only possible solution is that m equals 6. Okay, we're on to worked example 3, and now we're looking at some projectile motion. An object is thrust vertically upwards from the ground. The height, h meters after t seconds, is given by h equals t, the time, multiplied by 4 minus t. Work out the time it takes for the object to reach a height of 3 meters and explain why there are two solutions. Okay, so what I'm going to do here first is substitute the height equals 3 into the equation because I've got two variables. So what that's going to do now is make this part here a 3 equals this. Let's expand those brackets to 4t minus t squared, and let's rearrange or transpose that equation so we've got a 0 on one side. Okay, so what I'm going to do is bring the t squared to this side and the 4t to this side. So I end up with t squared take away 4t plus 3 equals 0. Now let's factorise that there. So we already should know how to do that. I'm not going to explain that in great detail here, but I've factorised it as negative 3, negative 1. And negative 3 times negative 1 makes positive 3. When you add them together, you get negative 4. Now I'm going to use that null factor law. That means t minus 3 equals 0 and t minus 1 equals 0. So my two solutions will be that the object is at a height of 3 meters at 1 second and at 3 seconds. And the reason is that I'm obviously throwing that ball at a height of exactly 3 meters or even more, because as it goes up, it passes through the 3 meters, and as it falls down, it passes through the 3 meters again. So that's why it has two possible solutions. Well, that's all we have time for in this video. I hope you found these types of questions helpful for you to unpack how to solve problems with quadratics. If you've got any questions, you can reach me at mcclutchymaths@yahoo.com. You've been watching McClutchy Maths. 2 more videos in this series to go. Have a wonderful day. Now I've got a non-monic quadratic.